Good morning, my YouTube viewers. Crystal here. I wanted to make you another video. I noticed in my recent videos there was lots of crackling and noise and things like that in my videos. And I think I figured out that the reason why is because on my screen recorder I had it set up to record system sound, and that's what a lot of the problem was. Unfortunately, I'm just here on my own. I have to figure things out on my own. I don't have anyone to show me. So I do apologize about the quality of my previous videos, and I hope this video works a lot better, which I'll make sure that I don't have the system sound on when I'm making videos in the future. But then again, it's because I'm just here all on my own, trying to learn how to use the software and coding and everything by myself. So what I wanted to do is I wanted to talk about the Amy's house prices, which was a Kaggle competition. So I wanted to show you the Kaggle competition, and I wanted to show you that the most recent work I've done, I did score 0.15314. Well, that's not my highest score. I got my highest score with XGB regressor, I think maybe even an ensemble. Yeah, I got my highest score with an ensemble. But I've done some work. I've done some more work on Amy's house prices, and this isn't an ensemble. And I wanted to go over this with you because I've done some more work and I've learned some more about sklearn, and because I've learned some more about sklearn, I wanted to share that with you and do a code review. So the first thing, it says right here that I'm sharing this. I'm sharing this, so you should be able to go into Kaggle and find the. You should be able to go into Kaggle and find this file so you can follow along with me. So the first thing we'll do is we'll talk about the problem statement. This is a Kaggle competition, and it says ask a home buyer to describe their dream house, and they probably won't begin with the height of the basement or the proximity to an east-west railroad. But this playground competitions dataset proves that much more influences price negotiations than the number of bedrooms or a white picket fence. With 79 explanatory variables describing almost every aspect of residential homes in Amy's, Iowa, this competition challenges you to predict the final price of each home. Amy's housing dataset was compiled by Dean DeCook for use in data science education. It's an incredible alternative for data scientists looking for a modernized and expanded version of the often cited Boston housing dataset. So this is what we're using. We're using the houses of Amy's house prices, but I might do some work on the Boston data set anyway, because I think with the Boston data set, I think they give you the latitude and the longitude, and I saw something this morning where they were plotting a graph of the latitude and the longitude, and I thought that looked really, really cool. So the first thing we do is we import our library, so you can see that we've imported our libraries. And the next thing we do, because I'm on the Kaggle website, we had to import the files into Kaggle. And the next thing we do is we load our data sets. So we read the data sets. So you can see the train file and the test file. You can see train. You can see the train file again and the train test again. And we describe our target variable, so you can see like the average of the housing prices. So we can see how the overall quality relates to the sale price. So the better the quality, the higher the price. Now what we're going to do is we're going to check for any null values for the test file and the train file. Now what we're going to do is we're going to impute missing values. And what I've done is I did something a little bit different this time, rather than just setting things up for the mode, because mode is your most frequently used answer. I decided, well, that's not good because we don't know what it is. So rather than just setting it up for mode, what I did was fill in A, and I said not listed. So that's actually creating another category called not listed. And I think that that's actually more accurate than using mode, because we honestly, those cells were blank, so we honestly don't know what was in those cells. So I think it's best to just set up another category and called it not listed. And then on the median, if it was an object file, it was not listed, and if it was a numeric file, it was median. So you can see in some of these files here, we do have median written down. So you just have to, what I had to do was I had to go through info, and then I had to pick the object columns out, and then I had to pick the median columns out. I just decided that I didn't want to use mode. I decided that mode probably was not the most accurate way to impute the missing values. So I just said not listed, which is the truth. And then I said median because I had to put something down there. So I did that for that file and the test file. And then we set up some more columns where there was a basement, it said none, and then other things. In A was 0, and garage fill in A 0. And so now what we do is we check for any null values, and we don't have any more null values. And then what we do is we say, now what we're doing is we're checking to find out all of the columns that were objects. And then now what we've done is we put all of these columns that were objects in an ordinal encoder. And the reason why is because the sklearn paperwork or documentation says that you're not supposed to use a label encoder for the X values, that you're only supposed to use the label encoder for the Y value or the target. And so I'm trying to comply with what sklearn wants. And the reason why is because if you do a lot of really unusual things, then what you're going to do is you're going to create noise in your system. And then when you create noise in your system, then that's going to reduce your accuracy. So now it's all in ordinal encoded, all of our columns, and I did all that. And that was for the train file and the test file. So now what we do is we set up our X, Y, and X variables, and I've already done that previously because I did features, and when I did features, I was picking out the columns that were detracting from my accuracy. So we removed all the columns that were detracting from accuracy. And now what we do is we split our train test up for testing and training. And so we've got a training set and a validation set in the train set. And now what I've done is I've done something new, and I've created a pipeline. And so that's what pipelines are probably, once you get the hang of a pipeline, pipelines are probably better because they keep you from making lots of mistakes. And so that's just what I did. I thought, well, I'll create a pipeline. And then when you create a pipeline, you don't have to worry about standard scalar or getting everything right on standard scalar, because in the past I hadn't been doing standard scalar right. And you don't have to worry about all that stuff because the pipeline does it for you automatically. And so we got 99.96% accuracy when I created the pipeline, and I used the gradient boosting regressor, and I used these other parameters. So now what we're doing is we're predicting our validation set, and when we predicted on the validation set, I got 95.21% accuracy, and then I also printed up the R2 score, gives you a 99.99 accuracy as well. And so now what we've done is we've got our data set, and so we've compared our actual values to our predicted values, so you can see, how these related. And what we're doing is we're testing on our test set, X test. We set up our final result. We set up our submissions into a data frame, and then we convert the data frame into a CSV file, and we submitted it, and I got a submission of 0.15314, which, as I said, it's not my best score, but it is a good score nevertheless. And so I thought, oh, well, I'll go ahead and make a video on it. And then I've been doing things better than what I had been doing before. So at some point I may go through and put GradientBoostingRegressor in there and see if I can increase my score with GradientBoostingRegressor. But as I said, this isn't my best score, but it's still a good score, so I decided to make a video on it and show you the new things like ordinal, encoder, and pipeline, and I put a standard scalar in there as well. So if you like my video, please like, subscribe, and share. If you like the work I do and you want to make a donation, I've got my email address to my PayPal account down below. I don't have enough subscribers, so the only way I can make any money on my account is to ask for donations. And thank you very much for watching my video, and I look forward to making new videos.